Okay, this lesson is over electrons and how they are found in atoms. It's an introduction to quantum mechanics, and we will go over the Bohr model, the quantum model, and electron configuration. Okay, just looking at the basics. Electrons carry a negative charge. We've discussed this before, so hopefully that's a review for you, that electrons are negative. They have a mass of 0.0006 AMU. They are much, much smaller than a proton or even a neutron. Okay, they are located in the region outside the nucleus, the electron cloud. If you'll remember, protons and neutrons are found in the nucleus, and the electrons are going to be found outside the nucleus. And remember also that atoms are electrically neutral, therefore the number of electrons will equal the number of protons. Okay, looking at the Bohr model, this was made up by a man named Niels Bohr, and it's sometimes referred to as the planetary model because the electrons are orbiting the nucleus like planets orbit the sun. Orbit 1, you see there where it says n equals 1, orbit 1 is closest to the nucleus, and orbits will increase in size and number as they get further away from the nucleus, just like the planets' orbits do from the sun. Orbits have a fixed radius, so they never change in size. So that n equals 1 is always going to be that same radius. It doesn't change. And the lowest energy is closest to the nucleus. Okay, that was the Bohr model. Now the quantum theory says that electrons are in discrete energy levels, meaning the further away the energy level is from the nucleus, the more energy it has, that there's no in-between energy. They're at the certain levels and there's nothing in between. Okay, the modern model of the atom, we've looked at Bohr's model, then the quantum theory, and now this is the modern model. The electrons occupy orbitals, not orbits, but are still in specific energy levels. Orbitals are called three-dimensional regions in space where electrons are likely to be found. They're kind of like an electron cloud, and there's not a circular pathway. They kind of rotate through this whole space. Here is a picture of the different orbitals. The first one you see there is the s orbital, and it's written really small in your notes, so you might want to write those down if you can't see them very well. The first one is an s orbital. The second one is a p orbital, and then we have a d orbital and an f orbital. Orbitals are going to be different shapes and sizes, as you can see from the picture, and the higher energy orbitals are larger and further away from the nucleus. And then those letters that we called those orbitals, the S, P, D, and F, those are just the sublevels, and they're based on the shape of the orbital. So looking a little closer at the s orbitals, here's 1s, 2s, and 3s. And as you go down the periodic table, you go down from 1s to 2s to 3s. And as you can see, the energy levels get much larger, and they increase in size as you go down. And now looking at the p orbitals, and this is into two different slides, and on your notes I know it's in one slide, but the p orbitals here, there's the z, x, and y, and that's the way that they rotate around that axis. So if you'll just look, the first one is rotating around the z-axis, which is up and down, and then the x-axis would go like side to side, and the y would go the other way. And you can see that the p orbitals have those two little clouds, and here's d orbitals. If you'll notice, I'm going to go back. D orbitals have the 4 different clouds that are alternating and rotating through. Just another look here at the different types of orbitals and how they compare to each other. The red ones there, you have the S's, then you have P, and then D's, and then you can see the F's are very, very, very complicated compared to the S's. So they increase in complexity as well. Okay, if you look here, this is showing you those different orbitals that we just talked about. This is like our map or seating chart for the electrons. So if you'll see there in the first two columns are the S's, and then all the transition metals are the D's, and then over there to the right of the transition metals is going to be your P orbitals, and then the actinide and lanthanide series down at the bottom are going to be your F orbitals. Okay, electron configuration is basically just a shorthand notation for describing how electrons are arranged around the nucleus. And there's some rules that you have to follow. You're always going to fill the lowest energy levels first, based on how many electrons the atom has. And then the other rule is there's no more than 2 electrons per orbital. No more than 2. So here's some examples. If you look at hydrogen on the periodic table, it has 1s1 because it only has 1 electron. Helium is going to have 1s2 because it's still the 1s energy level, but there's 2 electrons in it. And then if you look down, the one you need to fill in is lithium. It has 1s2 because it has the 2 electrons up there, and then it has 2s energy level, and it has 1 electron. So it has a total of 3 electrons. And we can check and know that's right because lithium also has 3 protons because the atomic number is 3. And then we look at cobalt. It's 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d7. And you can follow it as you go along the periodic table. And as you can see, it's a shorthand for showing you where, in what energy level the different electrons are in. And then there's another example there with bromine. Okay, and this is just showing you where those shorthands come from. If you look on the brown in the second energy level, that's 2s. That's where the first block would be lithium. So that would have been 1s2 and then 2s1. Okay, and that's just something you can refer back to when you're working with the shorthand. And then that slide, Oh, this was just showing you another one. This is showing you where you have, oh, that is on your notes. Never mind. The last one was not on your notes. This one is. This is showing you how you can go through and look for phosphorus and how it has 1s2 up through helium, then 2s2 up through beryllium, and then the 2p6 is where it's boron through neon. And then 3s2 is sodium and magnesium, and then 3p3, because you're in that 3p energy level, but it only goes over 1, 2, 3 electrons. So that's how you do that one. And then manganese is shown there. It's the same as phosphorus, except now it has 3p6, and then 4s2, and then it goes over 5 into that d orbital. So it's 3d5. Okay? And now this would be our last slide for this video. And this is showing you the order that we fill subshells with electrons. So it just kind of shows you the way you go because it's not always in the same order because you go 3D when you would think you would go 4D. So that would be it for the notes today. And we will talk more next time. Thanks.